The Great Red Spot of Jupiter is more than just a colorful feature. It's a centuries-old storm system that has fascinated scientists since its discovery. Despite being studied for hundreds of years, many of its characteristics remain elusive. Its true origin is unknown, and even its coloration remains somewhat of a mystery. The color of the Great Red Spot can vary significantly, ranging from a deep brick red to a pale, almost white hue. One prevailing theory suggests that the red coloration results from chemical compounds in Jupiter's atmosphere being broken down by ultraviolet light from the sun. This process is similar to what occurs across other areas of the planet, but the spot is unique in its structure and altitude. Interestingly, the Great Red Spot exists much higher in the atmosphere than the surrounding cloud layers. This elevation allows it to interact with sunlight more directly and intensively, which could explain the boldness of its color compared to the muted bands around it. The more intense the interaction with UV radiation, the more pronounced the coloration appears. But the Great Red Spot is not merely a colorful blemish. It's a storm of unimaginable proportions. Spanning over 16,000 kilometers at one point, it's large enough to engulf Earth 1.5 times. Winds inside the storm can reach speeds of up to 430 km/h, and yet the storm itself moves relatively slowly, rotating counterclockwise every 6 Earth days. Despite its massive scale, the storm has been shrinking over the past few decades. While this may seem alarming, scientists believe it is part of a longer cycle of atmospheric change on Jupiter. What appears to be a decrease in size may, in fact, be a transformation, perhaps a shift in the planet's meteorological patterns, or a temporary phase in the storm's evolution. The behavior of the Great Red Spot provides valuable insight into fluid dynamics, especially on a planetary scale. Jupiter's atmosphere lacks a solid surface to interfere with wind patterns, allowing storms to persist far longer than those on Earth. The massive energy dynamics and the Coriolis effect, resulting from the planet's rapid rotation, allow for stable yet dynamic systems like the Great Red Spot to persist for centuries. In recent years, spacecraft like Juno have provided unprecedented data. Juno's suite of scientific instruments has allowed us to peer beneath the visible cloud tops and study the structure of the storm in greater detail than ever before. What's been found is astonishing. The roots of the storm may extend over 300 kilometers deep, possibly involving layers of compressed liquid and even metallic hydrogen. Even more surprisingly, the Juno mission revealed that the red spot is not just an isolated anomaly. There are multiple smaller storms that orbit around Jupiter and even merge with or affect the Great Red Spot. These interactions offer a fascinating look at atmospheric chemistry and energy transfer on a scale not possible anywhere else in the solar system. But why do we care so deeply about Jupiter's storms? Beyond their aesthetic beauty, they offer a natural laboratory to study the extreme conditions of gas giants. The behavior of these storms can help us understand atmospheric patterns on exoplanets and even the early history of gas giants in other solar systems. Moreover, by observing how such a persistent weather system evolves, scientists hope to improve models of Earth's own climate systems. Despite the vast differences in size and composition, there are universal principles that govern the behavior of fluids and gases, and Jupiter is one of the best places to test them. As we continue our journey through the mysteries of Jupiter here on Infinity Beyond, we'll explore not only the dramatic tempests like the Great Red Spot, but also the more subtle processes shaping the entire planet. Stay with us as we dive next into the powerful magnetosphere of Jupiter, an invisible shield so massive it makes Earth's magnetic field look like a drop in the ocean.